Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5. And this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25. And this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125. And this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.